recording now? Okay, great. Hi, everybody. I'm Christopher Hans Soden. I'm one of the BRC consultants, and I'm going to be taking over the first half of this training on Savio. My colleague in the back there is Chris Patoric. He is also one of the consultants with BRC here, and also a professor in statistics. So this training is based off of our documentation that's online. Hopefully you've all been able to find this documentation on GitHub, and so you have access to it. We'll go through it a little bit quickly. I encourage you to go do things as we do them when you can, and where it's a little bit too fast for you, just come back and use this training as a reference and go through it on your own time. I'm going to be talking about how to get access to Savio, how to log into it, and the general system architecture of Savio. And then we'll go over logging in, getting data to and from Savio, and then managing the software on Savio. After that, Chris will take over with submitting jobs and actually getting the work done, as well as using Python on Savio. Savio is a Linux cluster, which is basically about 470, maybe a little bit more now, computers networked together to operate as if it was one machine. It is run under this condo model where about 40% of the nodes, or the kind of individual machines within Savio, are provided by the institution, and 60% are purchased by researchers and different research groups on campus and sit within it as part of this condo system. Don't need to update now. Okay, so the primary way that people get access to Savio is through the FCA, or Faculty Computing Allowance. Every faculty member on campus gets 300,000 service units, which are roughly equivalent to core hours on Savio. So just for reference, that's enough to have a 30-core machine running 24/7 for the entire year for every faculty member. Once the faculty members get those FCAs, they can then add any users to their allocation that they want. The second way that people get access is through the condo program. In that, you would pay for a certain number of nodes that live within Savio, and then you get priority access to that amount of resources whenever you need it. And then the third way that people get access is through an instructional computing allowance. So if you're teaching a course that has a heavy computational element, then you can come to us, and we can provide access to Savio for that course. That really works best for semester-long courses, unfortunately not shorter workshops. Okay, so I already said that Savio is this Linux cluster. You access Savio by logging into it at one of the login nodes. And on these login nodes, you can access your files and manage your files. But then from there, you submit jobs to the compute nodes, which will actually do your heavy computation. There's also the data transfer nodes, which are used for getting data to and from Savio. So they have more types of networking enabled on them, and they're configured to facilitate the large amounts of data that come and go from Savio. Okay, here's a conceptual diagram of Savio and kind of its networking. You all start right up in here. This is your maybe laptop or something, your workstation, and you use some kind of network protocol through the internet to access Savio. So that could be SSH is your primary login mode, SCP or FTP for transferring files, or also this service that I'm going to tell you about called globus, which is also used for transferring files. Through SSH, you will be assigned to one of 4 login nodes, and that's just randomly. And you can switch between the login nodes, but that's kind of divided up randomly so that there aren't too many people sitting on one login node and using its resources at one time. For file transfers, you can SSH to the DTN, or you can also use one of these other protocols in conjunction with the DTN. All of the nodes in Savio have access to its file systems. So I'm going to zoom out here a little bit so you can see the full diagram. There we go. So there are 3 main file systems on Savio, and every single node, no matter where you are or where you're working in Savio, has access to those same file systems. And we'll talk more about that. And then from the login nodes, you use the Slurm scheduler to submit or kind of request an allocation of some amount of resources for some period of time. The scheduler tries to find a slot where that's available and puts it in according to the rules of the scheduler, which we'll talk about. Yeah, and it may go to one of several different partitions within Savio. So we'll get into all of that. Any questions on this diagram before we move on? OK, we'll come back to it. OK, so as I said, there are several different partitions, which are pools of nodes within Savio. Every machine within a partition has identical architecture, but the different machines between the different partitions have different architectures or different resources. So if you go to the Savio training documentation, you can see the scheduler, or oh, sorry, that's the scheduler configuration, hardware configuration. So in our user guide, under hardware configuration, the Savio 1 pool consists of 164 nodes that each have 64 gigabytes of memory and 20 cores, while the Savio 2 pool has 136 nodes, 24 cores, 64 gigs of memory, and et cetera. So you can see the partitions that are available there and what their specific resources are. This is the same page. OK. A little bit lower down, under the scheduler configuration, you can see these are, again, the partitions, but this is how you would know which partitions you might have access to, or how to name them when you're requesting your jobs. So for example, Savio 1, the accounts starting with FC often have access to that. And some, if you have a condo allocation, you could look that up there. Great. OK, so the file systems on Savio, there are kind of 3 main areas of file systems. The primary ones are your home directory, which is going to be in this global home users, and then your username path. And then the Scratch directory, which is under global Scratch, and then your username. The home directory is limited to 10 gigabytes per user. So that space is designed to have your scripts, some of your kind of documents, and other personal type files. It's not designed to hold your research data. That should really go into Scratch. And some users will also have access to other file systems, such as the groups file systems, or other storage that they've purchased through the Condo program. That is designed to kind of archive and store data that's not currently being used. But anytime you're doing actual computation on a set of data, it should be within Scratch. And the reason for that is that Scratch is networked to the compute nodes and the DTN through the very fast InfiniBand architecture. And that's designed to handle the kinds of input and output that we get when we have thousands of users doing heavy computation. The home directory and the other file systems on Savio are just networked with Ethernet. If you do computation on data in those locations, it's going to bog down the entire system and prevent access to everybody. So please make sure that you keep your data in Scratch. OK, so now that we've gone over the overview, we'll get to actually logging into Savio. SSH is the method which you're going to use to gain access to Savio. And the format for that command, you're going to need to have some kind of SSH client. On Mac and Linux, that's just going to be there by default in your terminal. If you're using Windows, a good option is PuTTY, and your access may look a little bit different using PuTTY. But Mac and Linux users, your command is going to be SSH, then your username, and then there's two locations. For the login nodes, it's going to be hpc.brc.berkeley.edu. So I'll go ahead and log in myself. hpc.brc.berkeley.edu. OK. When you do that, you'll be prompted to be asked for your password. Your password consists of your personal PIN followed by the one-time PIN or one-time password provided by the Google Authenticator app. So I enter my personal PIN, and then immediately afterwards, I enter the one-time password. Great. And this you won't see. This is my GitHub. So that's just me. OK, so now I've logged into Savio. It drops me into my home directory. At the top of my terminal, you can see that I was assigned to login node 001. And I can look around, see that I have a bunch of files. I'm currently in my home directory. And my Scratch directory is going to be there. Cool.
So how do you set and reset your PIN if you forgot it?
Set and reset your PIN. The instructions for setting up the authenticator and your account are linked here. And so just kind of go through that on your own time. If you have difficulties with that process, you can contact us for help.
So the login node is random, right?
Yeah, the login node is random. Although you can specify a specific login node, I believe. Or once you're on, I can switch to a different login node. I do need to enter my password again. Sorry, one more time.
Is there a reason why would you switch? Like, and the same?
Yeah, so if there's a problem with one login node, then you might want to switch. If you're using a session manager, can't remember the name of some of the popular ones. Yeah, tmux, yeah, like that. Then that will be running on a specific login node. So to get back into that session, you would want to be on that node. If another user is behaving badly and running their computations on the login node, and that's bogging it down, then you can switch to one of the other three. And also, please let us know, and we'll stop that.
I mean, like, I guess, like, how would you know when things are not running?
So you can monitor the kind of status of the node using usual Unix commands. That's not right. Such as top. And so here I can see the top processes that are running on the login node, as well as some of the resources that are available. So if things aren't behaving well and you run top and you see that somebody's running a Python process that's using 700% of the CPU, then that could be a problem. Right now it's looking fine. OK. One option that you might want to know for this SSH command is the -y option. So this enables X11 forwarding, which allows me to use GUI type applications through SSH. is hpc.br, or is it brc hpc? Yeah. One of the joys of using Savio is getting to enter one-time passwords a lot. OK, so now I can run a program that has a graphical interface like Emacs. And rather than getting the Emacs within the shell, I now have a nice, Emacs window forwarded to my machine. If I didn't have that -y option, I would get it would just be within the shell. OK. So how do you get your data to and from Savio? So one of the easiest ways or simplest ways is with SCP or FTP. We're just going to go over SCP because it's more straightforward. SFTP, there's lots of guides that you can look up on how to use it, but it works fine with Savio. The syntax for the SCP command and using it with Savio is just your basic SCP commands, but make sure that you're going to be targeting that to the DTN rather than one of the login nodes. So make sure I have this bayarea.csv file. Good. OK, so I have this bayarea.csv file in my home directory on my laptop. And here I'm going to transfer that file to my account at the DTN. Remember that this tilde symbolizes my home directory / and dot. So I'm saying name it the same thing, just put it in my home directory. And again, one-time passwords. Oop. OK, so that transfer's happening now. If you want to change its name rather than a dot, you can just give it a new name, like right here. Or you can go ahead and put a full path, such as putting it in the Scratch directory. That's actually other Chris's Scratch directory. I forgot to change that one. And then you can also pull files from Savio to your local machine just by reversing this order, right? From Savio, this file, to my home. OK. One of the problems with SCP, or one of its inconveniences, is that you can only do one file at a time. And so if you have a directory with thousands of files in it, that obviously is impractical. So you can use tar, which is a tape archive program on Savio, to bundle up and compress files for offloading prior to the SCP command. So I'm going to go ahead and cancel that because it's going very slow in this room. But I will. Let's see, and do I have like a data somewhere? Where did I put it? Ah, there it is. OK, so I've got this data directory, and I can move some junk into it, like that bayarea.csv, into the data directory. I can also move this random test directory into data. Oh. Okay. So now I've got some junk in this directory, and I can use the tar command, like so, to create an archive. V is for verbose, Z is for zip, so compress it when you create it. And then F means to a file rather than to a tape archive. That, and I want it to be named my archive.tgz, and it's going to be that data directory. And so it tells me, oh, I'm compressing all these things and sticking them in this archive. And then to untar it later, it's almost the same command, except an X for extract rather than create. Okay, so that is simple and it works, but it can be a slight pain. So if you're moving large amounts of data, we highly recommend this service called globus. And globus can rapidly transfer files using a more point-and-click method, and it also will restart transfers if they fail. It'll let you know the status of them, and it will checksum the data on either side to make sure that it got across without any loss. So I'm going to direct you to our documentation on how to set up your globus account. But to transfer data to or from another device like your laptop, you're going to need to install this software Globus Personal, or Globus Connect Personal. And then you're going to need to set up your computer as what's called an endpoint in Globus. We've already set up Savio as an endpoint, so you can locate it through the Globus app. Okay, so the Globus app is this web app. And this is kind of what usually when you, well, maybe I'll log out first. Okay. Oh, they remembered my stuff. Oh, there it went. Okay, so you log in with your CalNet. Which you've all set up with the two-factor authentication, because we're very secure here. Okay, and you'll be brought to the transfer screen at first. For some reason, it only gives you a single panel, which I don't find very useful. So usually, go ahead and put it to 2 panels. And you want to look for a collection or endpoint here. And Savio's is going to be UCB #BRC. So that's it there. And that's Savio. And oh, I'm already logged in here too. That's weird. Okay, usually when you do this endpoint, it's then going to ask you to authenticate access to your data on Savio. So you'll click through there and you'll enter in your Savio username as well as your PIN and one-time password as if you were logging in with SSH to Savio. And once you do that, then you'll be able to see your data. Now, the other end of that I want to connect to is my laptop. So go ahead and open up a new terminal here. And this is going to be Globus. I have the Globus Connect personal software on my laptop, and I want to run Globus Connect, which I have previously set up. The setup for that is pretty easy. You, within the Globus app, you will go to your endpoints, create a new endpoint, Globus Connect personal, give it a name right here. You will generate a key, copy that key, and then the first time you run Globus Connect personal, it'll ask you for the key. You enter it in there. So I've done that. I connect. And in a moment, back in my file manager, I will be able to select my laptop's endpoint, which I've named Askaspor. All right, it's connected, and now it's active. And so I can go and find this bayarea.csv file and go ahead and transfer that over to Savio. Transfer requested, and I can view the details here. Seeing how many files, what point is it at, what's its status, etc. And just a side note, there's also a Globus command line interface. And if you want to read the documentation of that, you can use that to automate some of your transfers. For example, after you're done with an analysis, automatically transfer the results to your storage offsite somewhere. OK. The last data transfer method we want to go over is using rclone with, in this case, Box, but it's very similar for B drive. So as Cal affiliates, you have access to unlimited storage on Box and B drive, which can be very handy for moderately large amounts of data. Box does have a 15 gigabyte cap on the file size, and both of them do have limits on how much data you can transfer per day. If you aren't familiar with those, you can check out, they both have web apps and desktop apps to kind of sync files between your machine and the drive. And Globus, unfortunately, doesn't work for those because we can't set up endpoints for your own private B drive. But there is some software such as rclone, which is specifically developed to complete these kinds of tasks. So setting up rclone with Savio does require a little bit of setup. So, and we already have it installed on Savio. So here I'm logged into Savio. No rclone. I think you need to load it. Globus. OK, so you do need to load the module, but then rclone is there and available for you. I want to go, yeah. To set that up on Savio, you'll do this rclone config. And then on Savio, you're going to not do autoconfig. So a new remote. We're going to name this training box. And then select from the list. It's going to be box. OK. OK, I think you leave this blank. Oh, wrong one. That blank. Okay, now it asks you if you want to do autoconfig. You say no there. Then you actually have to go back to your own laptop. So this is on Savio. But this is a remote machine, and so you have to actually have rclone installed on your machine at home. And you do rclone authorize box. This is going to open up a browser. This is why you have to do it on your own machine, because you can't use a browser on Savio, at least not easily. And you will log in here with your CalNet ID to log into Box. When you do that, back in your terminal, it'll give you a code. You copy and paste that into the result here, and then you're done. Okay, once you've done that, there are some commands like rclone list remotes. They're pretty self-explanatory. And you can see that I have a Box account already set up for my lab association. And then you can list directories and files, copy files using those rclone commands. Okay, once you get some files on there and you need to edit them, you're going to need some kind of text editor. On Savio, we have 3 text editors available. Vim and Emacs are both available by default. And you've already seen Emacs. If you want to use Nano, you have to load that module. And now there's Nano. Okay. So I've been loading a few modules, and you may be wondering what's all that about. Software in Savio is stored in this module system. And that's not designed to be confusing, but it does enable us to have many different versions of software that don't conflict with each other, so that each user can configure their environment so that it works for them without getting in the way of other users. The commands for this are just simply module, and as well as the module load command, which you've seen me do. How do you know what software is available? You can do that with module list, which lets me know what modules are currently loaded. You can see that Vim and Emacs are already loaded whenever I log in. And I've since loaded rclone and Nano. And you can list all available modules with this kind of truncated available command. So there you can see all of the software modules that are available. One thing that trips people up is that some of the software is nested hierarchically, because software has different dependencies. So if you haven't loaded one of those dependencies, it won't show up in the available command, unfortunately. So when you're looking to see if something's available on Savio, you may want to start with loading some of the prerequisites, especially some of the common ones, like OpenMPI or the GCC or the Intel compiler if you're using that. So this OpenMPI should fail. So you go, oh no, there's not OpenMPI. But if I load the GCC first, that worked. That also prevents you from loading a version of the software that was built with a different version than you have loaded of some prerequisite. So it enforces that the dependencies are compatible with each other to some extent. OK, all right, that's what I have to say about getting onto Savio and getting your data there. Chris Pachork is going to take over with actually running some jobs on Savio. Any questions before I go? Yes? So the scratch space is theoretically unbounded. There's no user limitations, as you may have noticed. There's not a current schedule but it is prone to occasional clearing. So if it's getting full, we may come through and delete a bunch of old files. So you really should not use it for long-term storage of your data. It's not stable, it's not backed up, and your data could be cleared. That is done, I believe, on data that is 6 months old or longer.
Yeah, we're still sort of coming up with a formal policy on when exactly and how to do that. So it's been a bit of a,
Yeah.
a sort of manual process.
Yeah, so I can't give you like an every 2 weeks data gets cleared, but if your data is less than 6 months old, you should be safe. Yeah.
One question about the error message I often get with rclone. If I just type rclone ls my class, for example, it gives an error message, errorless list files get just give the API box, api.box.com. Are you familiar with that?
Listing files. I think we'd be happy to take a look at that. Yeah, I'm not familiar with that. And yeah, but I think at the end we're going to go over some ways you can get more help and some of our resources that are available to you. So that would be a great question for those kinds of things.
Is it a way to easily transfer from your scratch space to the group space, or do you have to transfer to your laptop and then through Savio again to the group space?
No, yeah, you can transfer between the different file systems on Savio as you would between different locations on your normal computer. Yeah.
So you could just use the cp command, for example.
Yep.
Direct.
Yeah, MV or CP work just fine. All right, thanks.
OK, let's go ahead and get started again. So I'm going to launch into talking about submitting jobs and how you go about doing that and how you know basically what accounts you can submit under and how you would submit different kinds of jobs, jobs that are running in serial or in parallel, those sorts of things. So the first thing to know is Christopher mentioned this idea that there are different partitions. And so you may or may not have access to a particular partition, which is a particular group of nodes that all have the same hardware, without running the command that I'm about to show you. So this is quite a useful command. So this saccount manager show associations. And so what you would do is you would do that, and then you would enter user equals and then your username. So I'm going to enter my username. This is going to produce rather more voluminous output than you would get because I have access to a number of different accounts because of the particular position I have. But the key things that we can see here are if you have access to a faculty computing allowance, you're going to see some lines that look like this. And basically what this shows in the, it's a little bit hard to read here, but in the fourth column here, separated by these pipes, what you'll see is that with the faculty computing allowance, you have access to, for example, GPU nodes. You have access to the HTC partition, which I'll talk about a little bit later. You have access to the big memory nodes on Savio 2, and you have access to Savio 2 and the Savio 2 and Savio partitions. So under a faculty computing allowance, you would have access to all of those at a normal priority. So that means you can submit jobs, and you'll be sort of in the queue with everybody else to get access to those jobs. And the fact that you have normal access is indicated by this Savio_normal over here in one of these more right-hand columns. If you have access to a condo, that means that you, or if you're a PI, you or the PI that you're working with has actually purchased nodes on Savio, and that's what Christopher was describing before. So in this case, I have access to a particular condo that's basically run through the statistics department. And so I see that down here in some of these additional lines that are produced as output from this saccount manager command. So what I see down here is these are all the partitions that I have access to through my condo association because I'm associated with a condo. But you'll notice for a lot of these, many of these have Savio_low priority associated with, listed here. And what that means is I don't have regular, normal prior access to those because I didn't purchase any of those kinds of nodes, or we didn't purchase any of those kinds of nodes. The ones that I have regular access to are the ones that have a normal, so this stat GPU2 normal and the stat Savio 2 normal. So those are the two partitions, Savio 2 GPU and Savio 2, which I have access to as part of my condo because we purchase nodes that are in the Savio 2 and Savio 2 GPU partitions. So in general, if I were using the condo, I would want to use one of those two partitions because those are partitions where I have sort of access that's guaranteed by the purchase that we've made. You can also run jobs at a low priority setting, and those jobs are subject to being canceled if other people who have higher priority come on and want to use those nodes. I'll talk about that a little bit more in a few slides. But that's the basic distinction that you would be looking at, is whether you're in an FCA, which means you have regular access to all kinds of nodes, or most kinds of nodes. There are a few exceptions. Or if you have a condo, which means you have high priority access to the kinds of node that you bought, and lower priority access to the things that you didn't buy. OK, so any questions on that front? OK, actually, I guess I got ahead of myself because that was actually the next slide. So let me give a little bit of an overview on submitting jobs. It doesn't really matter which order I went in. So basically, when Christopher already said this, when you submit a job, the basic sort of workflow for working on Savio is you'll log into the login node. Christopher already demonstrated that. And then you will change directories to wherever you have a job script that you want to run. And we'll talk about job scripts in a minute. And once you've changed directory to where you have a job script written, you can then submit that job script as a job to the scheduler. And what will happen is that if we go back to the schematic that Christopher showed, so here you are, you're on a login node, you've changed directory to the directory you want to be in. You then submit the job to the scheduler, to Slurm. And Slurm will then put your job on one or more of these nodes, depending on how many nodes you've requested. So the job will be running on one of the compute nodes rather than running on the login node, but you've submitted the job from the login node. And in general, when you submit the job, the current working directory of where the stuff in the job, where the code in the job will run, is the directory from which you submitted the job. Now you can change directories in your script if you want to, but by default, that's the directory that it will be running from. So that's the basic workflow. If you find yourself doing something where you're starting to run some computations without using either the sbatch or the srun commands, it means you're doing something wrong because you're going to be running your code on the login node. And that's we really only allow you to do that if you are just running, if you're doing a compilation or if you're moving files around, and a shorter compilation. If you ran a compilation that takes like an hour, we'd want you to do that on the compute nodes as well. Or if you just want to do something really quick, you want to start up Python and just like check if you can run a few functions or something like that. That would be OK to do on the login node. But if you end up running a computation for more than like 5 minutes, and if you're going to use more than one CPU, that's the sort of thing you should be doing via Slurm on the compute nodes. OK, so I already discussed this idea of figuring out what partitions you have access to. OK, so the next thing is to give you a sense of what does it look like to actually submit a job to Slurm. So what you would be doing is you would be writing a shell script that basically is just a text file that looks something like this. And this is a little bit of a funny script because it has all these comments up here with the hash marks. Some of these comments are really instructions to Slurm on how to submit your job. And then the things that don't have comments are the actual code that you want to run, which is the actual computation you want to do. So in this case, you'll always have hash bang bin bash up here that says that this is a bash shell script. And then any place where you see the hash mark and then the capital word sbatch, that's an instruction to the scheduler of how to go about running your job. So the sorts of things that you would put in here is you can optionally name the job so that when you sort of query the different jobs that are running, you see the name of it. You would generally need to say what account you want to run under. So in this particular case, I'm running under this condo that I just mentioned. If you have an FCA, you would be writing something here like FC underscore in the name of your FCA. And then you'd be saying what partition you want to run in. So for example, I could run in the Savio 2 partition. And then oftentimes you would be saying how many cores and how many nodes do you want to use for your job. And we'll see that in a little bit. By default, if you don't say anything, you're going to get access to a whole node on almost all of the partitions except for one that I'll mention a little bit later. And then the other thing that you're required to put down is a time limit. If you're on a condo, then the time limit will depend on the condo. But for most users, the maximum time that a job will run is for 3 days. So you could put 3 days on here. If you know it's going to run rather shorter than that, you should put a more realistic time limit. And the advantage of that for you is that may mean your job will start running more quickly because the scheduler is trying to juggle different jobs. And if it's a short job, it may be able to sort of fit it in amongst all the other jobs that are running. And the advantage for us is that the Slurm scheduler can better manage all of your competing jobs if it has a realistic estimate of how long the job will take. Now, it's a bit of a catch-22 because sometimes things happen that you're not expecting and a job takes longer than you expect. So you're like, oh, I think this will take an hour, and you find out it takes an hour and 5 minutes. That means the job's going to get killed after an hour, and you'll lose all that work unless you've saved output temporarily in some fashion. So you can be on the generous side in terms of putting down the time limit. If you think it's going to take 3 hours, you might put down a time limit of 6 hours just to be on the safe side.
But I have a question. So if it finished before, it doesn't count on your time?
No, you're charged for the amount of time the job is running, not the, I'm pretty sure you're charged for the amount of time the job is running, not the amount of time that you requested. Yeah. OK, so these sbatch commands are the things that say how the job should run. And then down here is basically just the code that you want to run. So this could be invoking Python or MATLAB. It could be invoking some bioinformatics tool that you're going to use. It could be invoking MPI run if you're running a job across multiple nodes and you need to use MPI if you know what that is. Here, all I'm going to do is I'm just going to run a very basic Python script. So I'm going to load the Python 3.6 module. So Christopher talked about loading modules. And then I'm going to run Python and just run the Python code that's in this calc.py function. And I'm going to redirect the output and any error messages to a file calc.out. Okay. So let's just do a demo of this and see what this looks like. OK, so I should have, if I look at this job.sh file, that should be essentially the same as what I just showed you in the slides. Okay. And if I look at calc.py, that is really just some Python code. I'm a statistician, so a lot of what we do is linear algebra. So all I'm doing is I'm just doing some linear algebra here that happens to be fairly intensive linear algebra calculations. It doesn't really matter what it is for the sake of this demo. So in order to submit this job, all I need to do is run sbatch and then the name of the job script that I just showed you there. Okay. And you could create the job script on your laptop and then copy it over in the way that Christopher was talking about. Or you could create and edit the job script on Savio itself using Vim or Emacs or Nano, the tools that he just mentioned. OK, so I'm going to do sbatch of job.sh. And you'll see that it reports back the ID of the job. And this is going to be useful potentially in the future for sort of querying the system and seeing what the status of your job is. And so some of the things we can do in terms of looking at the status of our jobs is we can do sq-j. And that will show us some information. We can do wwal-j and then the job ID. So let's go ahead and do that. I could, for example, do sq-j 5034688. And that will show you that that job is pending. And the reason that it's pending is because there aren't any nodes available to run the job. And I'm now basically in a queue of jobs that would be run in a certain order. So I'm going to cancel this. I'm going to do scancel and then again the number of the job. And for the purpose of this training, we set up what's called a reservation that basically reserved 2 nodes for my use to do the presentation. So we're going to do ---- reservation equals Savio 3-training. So you wouldn't usually do this reservation thing. That's just for the purpose of getting access to the nodes on an expedited basis here. OK, and then I would still need to do the job.sh. Oops, I need to do sbatch here. OK, so I'm just resubmitting this job under the reservation. And now I got a new job ID. You can see it incremented a little bit relative to the old one. It incremented by 4, which means that there were a few jobs in the interim that somebody else submitted that got the IDs in between. So now I can do sq-j 5034692. And now it shows that that's pending, which is a little bit odd because I have this reservation set up. I'm actually not sure why it's doing that.
Can you give an estimation of how long you can wait for the job to start?
What's that?
Is it possible to have an estimation?
There is a command, I think, to do that, and I'm forgetting what it is off the top of my head. Yeah.
Your reservation was at Savio 3. Why did the job go to Savio 2?
Ah, that is the problem. Thank you. It's always good to have extra eyes on the task here. So I'm going to go in and edit this file and change it to Savio 3. So most people don't have access to Savio 3, and I generally don't use Savio 3, which is why the demonstration was for Savio 2. And then it turns out that in order to set up the reservation, it made sense to do it on Savio 3. OK, so let me cancel that again. And let's submit this again. OK. Let's see. OK, so it may be that it doesn't like this account for this. Yeah, it's probably that. So this is a special account that I have access to because I work for the program. OK, so hopefully this will now work. OK, so now we can do the SQ command and see what happens with it. So that was now 503.4695. OK, so that is now running. And we can see that because of the capital R here, whereas before we saw the PD, and that was for pending. Okay. And it's been running for 8 seconds. And I can do things like wwall -j, and again, this 503.4695. Not sure why that happened. OK, so I think that would usually work. I'm not quite sure what is. So did I get the job ID? 503.4695. Yeah. OK. All right. So I'm not quite sure why that's not working. That should, in general, work. I can also do things like SQ -u and then my username, and this should show all of the jobs that I have. Oh, I see. OK. This should show all the jobs that I have that are running. At the moment, there's nothing running, and that explains why wwall didn't produce anything, because in the time that I was monkeying around trying to type in the commands, the job started and finished, and there was no job running. So this warning is not very helpful, and obviously it didn't clue me into what was going on, but no node selected is an indication that the job wasn't actually using any nodes because it wasn't actually running. So let's see if that job actually produced any output. So this calc.out was the output file that I created, and if I look at that, we can see that it produced whatever numerical output I asked it to produce. So it did actually run. For the sake of illustration, I'm going to run the job again. And this time, I'm going to hopefully do wwall quickly enough that we can see what it shows. OK, so you can see that it's basically showing the total CPU utilization here and also the amount of memory being used. And so if the Savio 3 nodes, it looks like, have about 96 gigabytes of memory, and that's what's being shown here. And my job is only using about 3 gigabytes, so it's not really using very much memory, which is good. If you start to see this getting up to like 80 gigabytes or 85 or 90 gigabytes, that would be an indication that your job might run out of memory and it might get killed because it ran out of memory. So this is a good way to monitor that. The other thing that's quite useful here is monitoring the percentage of usage here. If you are running a Savio job on almost all of the partitions except for the HTC partition that I'll mention briefly in a little bit, you get access to the entire node and you are charged for the entire node. And so what that means is you, in general, don't want to be running a job where you're only using one core on the entire node because you're basically wasting all of the other cores. If you need to do it, you can do it, but you would be charged for it. And so this is an indication that I'm only using one of the cores, one of the CPUs on this particular node, because 3% of 32 cores is basically one core, 1 out of 32. And so ideally, what you would see here is 100% or a high number near 100%. So this is an indication that my code was really only running basically serially. It wasn't using any parallelization. And I'll talk in a little bit about some strategies for how you could try and make use of all of the cores on a node. OK, so any questions? Yeah.
Is there a version of wwall where you can monitor these numbers in percentages in time?
Oh, over time?
Over time. They change.
There is a command that we'll see in a second that will tell you after the job has run what the result is. You can do things like the watch command in Unix. If you did like watch -n1 wwall -j 503.4700. This job is now finished, I think, but watch basically just refresh the output, and you can just see it sort of doing it in real time. Other questions? Okay. All right, so let me go back to the slides, partly just to remind myself of where I am. Yes?
Is there any command
To list the running jobs, yes. So that's the SQ command would show all of your jobs either pending or running. So I would do -u Pechoric to see mine, Or if I wanted to see all of them, I can just type SQ, and that will now list out all of the various jobs that are running and pending on Savio. So this would be a way to get a sense of what's running and how much is running. OK, other questions? There are a few other things that you can do here in terms of looking at the stat at how much resources were used on a job that has already finished. And you can actually log into the node into a node that you're running a job on and run top to be able to sort of see what's happening on the node. So there are some commands for that here that I won't go through in detail. OK, let me say a little bit briefly about parallel job submission. So in addition to specifying the time limit and the account and the number of nodes, and the partition that you want to run on, you can also specify basically the amount of what kind of resources you want. And what I mean by that is basically how many nodes and how many cores you want to use for your job. So if you want to use more than one node and do parallelization across more than one node, you can specify the ---- nodes flag, and you would put this in the same kind of style as you do here. You'd have an SBatch line where you put ---- nodes, for example. You can also say how many processes you want to run per node. This would often be used if you were using MPI, and basically there the number of MPI processes corresponds to this word of tasks here. And you can also say how many CPUs you want to use per task. So depending on exactly what you're doing, the notion of what a task is may change. But what's going to happen when you do this is going to determine basically how many nodes Slurm assigns to you. And it will also result in setting some environment variables inside your job that can then be used to basically understand that your code or other code that other people have written can use to understand how many cores are available and how many nodes are available. So that will all be set based on having passed these flags in here. So here's an example of that if you were running a job that uses MPI. So one of the main ways that you would use multiple nodes on Savio is if you're either writing your own MPI code or you're using some software where somebody else has set up that software to use MPI. And MPI is a protocol for basically passing information and data from one node to another. So if you're going to parallelize across multiple nodes, you need to get information between the nodes, and MPI is the way that you do that. So here's a little bit of an expanded job script. So this is just like that job.sh file that I showed you before, except now it's basically set up to run some MPI code in parallel. And so I've added this flag here, --n tasks equals 40. And this is on, I think this would naturally be done on Savio 1 because Savio 1 has 20 cores per node. So this would naturally amount to having 20 cores per node on 2 separate nodes for a total of 40 processes or cores. And so if you set this up this way, when you then load in OpenMPI and you run a job via MPI, MPI will actually communicate with Slurm and will realize that you have asked for 40 tasks. And what that means is it will start up 40 processes to do the parallelization. And MPI will then be managing the communication between those 40 processes. So if you're not familiar with MPI and that didn't mean much to you, that's OK. But for those of you who know something about MPI, hopefully that was helpful. Yes?
Is that 1 per core?
What's that?
That's 1 per core.
Yeah, and you don't really need to set the CPUs per task in this case. The default is actually 1. And there are ways that you could combine MPI with also using threading, so you could have tasks that use more than 1 core. But in general, you only want to use, in general, you don't want to overload your cores. You want to basically have each core running at 100% of CPU. And so either you'd want to have 1 CPU per task and as many tasks as you have cores, or you'd want to have fewer tasks than cores and have multiple cores per task. So there's some arithmetic you can sort of work out to think about that. And so the sort of common sort of things that you might end up with is sort of what I just said: an MPI job with 1 CPU per MPI task, an OpenMP or a threaded job on 1 node where you have multiple CPUs for 1 task, or you could do a sort of a hybrid sort of thing. And there's lots of variations on this. We have some guidance here in this link on submitting jobs in these different flavors. And we're happy to take questions on sort of this sort of thing of like, what's the best way to sort of set up parallelization with some particular software that I'm using? But one thing to keep in mind is, in general, it doesn't make sense to ask for more than 1 node unless you know that the software you're running is capable of being run on multiple nodes. Some software is, but lots of software is not. OK, let me say a little bit about interactive jobs. So in addition to using sbatch, which will submit what's called a batch or a background job, you can also actually run jobs on the compute nodes interactively, where you're just typing away, and you can just sort of see what's happening on the fly. And that's a good way to sort of prototype your code, or if you need to do something where you really need to interact with the system. The same rule applies that you're going to get the entire node, and so if you're doing something interactive where you're not doing it in parallel in some way, you're still getting charged for all of those CPUs, even if you're only using one of them. So let me go back here, and we'll just briefly see what it looks like to run interactively. So OK, so you would basically execute code that looks like this. And now what we're doing is we're running srun, and we're going to pass those flags that I put in the job script. We're going to pass those flags directly from the command line. So in this case, I'm again going to use the reservation. So I'm going to change this to Savio 3, and I'm going to change this to AC_SCS guest. And I'm going to change it to ---- reservation equals Savio 3-testing. So you wouldn't have to put the reservation in. You often wouldn't have to put the account in if you just have one account, or if you want to use your default account. You generally would need the partition, and then if you're doing more than one nodes, you would want to put in the number of nodes. In this case, I don't actually need that, although I could leave it in there. OK, so the requested reservation is invalid. Was it called something else? Oh, Savio 3-training, not testing. OK, so you'll notice that my prompt here says that I'm on login node 2. And once I hit this and am allocated a resource, the sort of main clue that you have that you're actually running a job interactively on the compute node is your prompt will change, and it will show you the name of the node that you're running on. So in this case, I'm running on node 0069.savio3. And if I do something like hostname, it should actually confirm that that's the node that I'm on. And at this point, I can do whatever I want. I can do module load MATLAB or Python. I could run that Python calc.py script that I ran. I could do whatever I want. OK, so questions? Yes.
So, for instance, if you have a very intensive job, and then you check the memory, you're using like a whole node, and then you check the memory, and it's what you said, maybe like over 80%, then that means that probably you should be using 2, even if you're not using parallelization?
No, that's a great question, and I'm glad you asked it. It means that you should either A, try and see if you can somehow reduce the amount of memory your code is using, or B, use one of the big memory nodes, or C, the only time that you can actually take advantage of the memory on multiple nodes is if the code that you're running can actually run on multiple nodes. There's no way to share memory across nodes while you're having a job run on one of the nodes. Yes?
What if your job consists of multiple smaller jobs that each of them are independent?
Yeah, I'm going to get to that in a second. Other questions? Okay. So let's go back. I'm going to remind myself where I am here. Same thing on the interactive nodes. You're still charged for the entire node. If you
Are nodes shared?
No. So if you're running a job on a node, you get access to the entire node, and nobody else can do anything on that node, which in some ways is good, because that means you're not competing, for example, for memory on the node. In terms of if you do want to run stuff with a graphical interface, we have a visualization node that allows you to do that. And there are ways basically to connect a visualization node to a compute node to run things like Python or RStudio. So there's some information here. That's also something we can help with on a one-on-one basis. The low priority queue, I don't think I'll spend a lot of time on this. I mentioned it before. If you do have access to a condo and you want to run a very large job, or you want to run a job if you want to run a job that uses more nodes than you purchased, or if you want to run on nodes of the type that you didn't purchase, you can run in low priority mode. And this is a good way to run like a very big job that you are willing to wait to have it run. Well, that's sort of a bad way of phrasing it. That you wouldn't mind having the job killed. So you're not going to get charged for that job, but the cost is that the job could be killed and you might have to resubmit it. So if you notice that Savio is not that many nodes are free, you could then decide that's a good time to run a low priority job and hope that it doesn't get killed. And these kinds of jobs are also jobs where you hopefully would want to be able to save your output on an interim basis and restart your job from wherever it got killed. So if you can set up a job to do that, that also would work nicely with the low priority queue. OK, so let me go back to this question of whether you get access to the entire node or not. So the two partitions where which are allocated on a per core basis are Savio 2 HTC and the Savio GPU partitions. And on those ones, you will basically ask for 1 or 2 or 3 or 4 cores, or CPUs, and you would get access to those. So here's an example. This is just an interactive job, but you can do this with SBatch as well. I'm saying I want to use the Savio 2 HTC partition, and then I say I want CPUs per task to be 2. So that means I want to get 2 CPUs that I can then run my code on. So I would ask for 2 CPUs if I had set up my code such that it could use 2 CPUs. If it was just a serial job that would only use 1 core, I would change this to be equals 1 here. So that's a good way if you have jobs that you can't naturally parallelize. You can use these cores. And these are charged per core as well, so you're not going to be charged more than you're using. Same thing basically holds for the GPUs. You would ask for however many GPUs you want, and then we ask that you request twice as many CPUs as the number of GPUs, and then you would be that's what you're then charged for. OK, any questions there? OK. Let me say a little bit partly in response to the gentleman's question about what if I have a lot of smaller jobs that maybe each job can only use a single CPU. So the tool that we really recommend there is something called hthelper, which stands, I think, for high throughput helper. And what hthelper does is you basically give it a list of the computational tasks that you want to run. So maybe you have 1,000 things that you want to compute, and they can each be done independently. And each one of them often would only use 1 core, but each one of them could, if you want, use, say, 2 cores or 3 cores or something like that. What you would then do is you would write some code that uses this hthelper, and it basically you would write the code to basically tell hthelper how many of these tasks you need to run and what the code is that needs to get run to actually execute each task. And then you would submit the job. You would write your job script, your Slurm job script, to call hthelper with the particular invocation that is given in this documentation. And what hthelper will do is it'll say, oh, you gave me 1,000 things to do, and you started a job where you asked for 2 nodes and, say, 48 cores on Savio 2. So what hthelper will then do is it'll basically set up a little scheduler inside of the Slurm scheduler, and it will start up 48 of those 1,000 tasks at the start. And when one of those 48 finishes, it'll start the 49th one. And then when the next one finishes, it'll start the 50th one. And it'll just walk its way through all of those 1,000 tasks. And the nice thing that will accomplish is it will keep 48 cores busy until you get to the end of the computation. So you'll effectively be using the entire 2 nodes in the example I was giving.
Would that work if one of them are dependent on the other?
No, it wouldn't work if they're dependent on the other. So you really want these to be independent tasks. I suppose that if the tasks were sort of far enough apart that you knew one was going to finish before the other, then it might work. But there's sort of no guarantee of when things will necessarily finish. So generally, you'd want them to be independent. Yes?
How does that interact with wall times?
You would want the wall time to be the total wall time for the entire 1,000 tasks.
So if it terminates early, I can't restart it.
I mean, if you wrote output, say, suppose you got 500 finished and you wrote the output from the 500, you could just change your code to do the next 500 in the next job. Yeah. There are also lots of ways in tools like Python, R, and MATLAB where you could basically do something a little bit like what I just said, which is you would write your R, Python, or MATLAB code to work in parallel, and that will often work nicely across cores on one node, and there are tools for Python, R, and MATLAB that would allow you to run across multiple nodes as well. So if you're working with those tools, then you can also make use of multiple cores for independent computations. OK, so let's see. We're running a little low on time here. Let me see what I want to focus on here. We've already sort of covered most of this about sort of checking the status of jobs. This sinfo command is useful because it will show you how many nodes are free on a given partition. So this would give you a sense of whether if you submit something right now, is it likely to start running soon, or does it seem like the system's really busy? So you'll notice here, this is Savio 1. There are 81 nodes that are allocated that are being used right now, and there are 7 that are idle. So this is an indication that there is some free resource on Savio 1 that you could potentially make use of now. The other thing I'll mention is this check usage. So if you're running under an FCA, you have a limit of this 300,000 core hours. And so if you want to know how much of the 300,000 core hours or service units have been used during the year that we're talking about, you can run check usage. And so if I did that, for example, I think a better example is there's an FCA called Geisler that I'll look at. So this takes a little bit of time to sort of do whatever arithmetic it needs to do to sort of compute how much usage has been made over the past since June when the FCAs were reallocated. Okay, this is going a little more slowly than I expected. Okay, so this says that under this FCA there have been 87 jobs run since June 3rd of this year. They've used 21,000 CPU hours, and that's made up 26,000 service units out of the allocation of 300,000. So this particular FCA, they've been doing some computation, but they're not all that close to the limit of what they could use. Okay, any questions there? Okay, so the last thing I'll do is I'll just show you a brief demo of running some parallel code in Python, and then we'll quit. Okay, so I'm going to do sort of something similar to the sorts of things we saw that Christopher was showing. So I'm going to copy bayarea.csv into my Scratch directory, because that's where I want to do data input and output from, is from the Scratch directory. So I'm going to get my input data there. This pip install is just an example of if you want to install your own Python package in your home directory, you can't just use pip install because it would try to install in the system directories and you don't have access to those directories. But you can use this ---- user flag, and that would then install it in your home directory. And so in this case, it says, oh, stats models is already available, so it's not going to go ahead and install it. But if this were a package that were not already installed, this would be how you would run that. Okay. Oh, actually, I forgot. I was still in my srun session, so I was still getting charged for that session. So if I wanted to get out of that and stop being charged, I would type exit. Okay. So now I'm back on the login node. And so now at this point, let's suppose I wanted to run that Python code in an interactive session. I could do the same thing. Again, I'm going to change this to Savio 3. I'm going to change the account. And I'm going to put the reservation in. So that was equals Savio 3-training. OK, so now I'm back on that same node. And actually, I now have access to 2 nodes. If I did env and I looked for slurm, this gives all the environmental variables in the shell that are being set by slurm. And you'll notice, for example, it says the number of nodes is 2. So that's an indication I have an allocation of two nodes to do my computations on. OK, so at this point, if I'm running Python and I want to run the ipython parallel tool to run across multiple nodes, I basically need to start up Python worker processes on all 2 of the nodes, 1 worker process per core that I have available. So that's basically what this syntax is going to do here. It's going to load the modules I need, and then this IP controller and IP engine are basically going to start up a sort of master controller process and a whole bunch of worker processes. And what srun does in this context, which is different than srun in this context up here, is if I run srun within another srun or srun within an sbatch, it will basically run this command here, whatever comes after the srun. It will run that command on all, basically once for each of the cores that I have access to. So this will start up 48 different Python processes. So I could go ahead and do this. There's a bunch of sleep commands in here because I need to pause and wait for the earlier commands to finish before I start up the later commands. Oops. But it's sort of pausing. I probably actually need to make this sleep for longer to give it enough time. But basically, this is how you would start up all these workers. And once you've started up the workers, you could then start ipython. And then in ipython, there's a whole bunch of code here that just gives a demo of running Python code in parallel. So I think for the sake of time, I won't go through exactly what this is doing. You would need to either you might be familiar with ipython parallel, or you need to go sort of look up the documentation and get a sense of how this works. But there's at least a starting example of some code that would work. If I, for example, do ps aux pipe into grep python, I should see a whole bunch of Python workers running here. So there's a list of a whole bunch of Python processes, and that's an indication that those worker processes have all started up, and I should be able to have access to them. In this case, I'm just going to exit out rather than fully completing the demo here. Okay, so I know that was fairly abbreviated, but are there any questions at a high level about what I was doing there? Okay, I'll just mention a few things just to wrap up here. So one is that there's a nice package in Python called Dask that does a really nice job of managing parallelization across across the cores on one node or across multiple nodes. So I didn't put any documentation in here for Dask, but we did give a training last spring on that, and there's a link to the training here. And I've also prepared a tutorial on using Dask, and that's here. And then there's tons of resources online over and above that. But if you're somebody who uses Python or is interested in getting started on using Python, and you're interested in doing stuff in parallel, I would recommend making use of Dask. The other nice thing about Dask is if you have a very large data set, for example, one that wouldn't fit in memory on one node, sort of going back to your question, you can use Dask to basically operate on a single data object that gets split up across multiple nodes. You'll use the memory of those multiple nodes, and you can also then use multiple CPUs to compute on that very large data set. So Dask makes that fairly easy to do. OK, so let's wrap up with a little bit more information about getting help. So if you have a Savio-specific question, how do I do something, this isn't working, something seems wrong on the system, any of those things, just send email to this address, and one of the systems administrators or one of the consultants will respond to that, and we'll try and help you. If you have a more general computing question, for example, BRC, Berkeley Research Computing, can help you get access to not only to Savio, but to resources more broadly on campus or in the cloud or to NSF resources across the country. You can email us at brc@berkeley.edu, and again, one of the consultants will get back to you. We also hold office hours, so you can just drop in if you have questions. And then we also do consulting around data management. If you have, for example, confidential data, health data, educational data that needs to be protected, we can help you with that in terms of how to protect it in terms of storage and also where you can do computations with it. So you can email researchdata@berkeley.edu, and we hold the same office hours both for computing and for data. So you can come for either of those sorts of questions. And then I'll just mention a few things that are coming up. We have an open house and some training on working with secure data, including working with secure data on Savio, which is now possible. And that'll be in about a month here. I think it's going to be here at 3 p.m. on Tuesday. We're usually looking, and we are now looking to hire additional consultants to help people like you. So if you're a graduate student and this sounds interesting to you, we have some flyers in the back, or you could just ask us if you have questions about this. And is Amy back there? Yeah. Amy, I forget the third thing that you wanted me to mention that I didn't get a chance to put on here.
The cloud meetup.
Oh.
So anybody who's interested in cloud technologies, we hold a monthly meetup at the Skydeck, always the fourth Tuesday.
What's the Skydeck? That sounds very futuristic, but people might not know what it is.
It's in downtown Berkeley, and it's where startups start. So you're welcome, and we have pizza there too.
So do we have snacks now, pizza out here? OK. So are there any questions before we break? Yeah.
Is there ipython notebooks remote? Can we access like?
Yeah, there's a slide that I skipped over for the sake of time where you can use Jupyter Hub to access notebooks, or you can go through the visualization node. The visualization node is a little bit more robust in terms of if there's an error, you can sort of see what's happening more easily, but those are the two ways that. If you're just running sort of a low computational burden job, you can just run it on the Jupyter node, and that won't get charged anything. If you're running something in parallel, then you'd run it on a compute node, and you would get charged. Yeah. Any question in the back? You'd use the interactive node if you, for example, wanted to bring up an RStudio session or a graphical interface to a Jupyter Notebook or a graphical MATLAB interface, and then be able to like point and click and those sorts of things. So, OK, well, let's break here. A few of us are mingling around. We're happy to answer questions one-on-one. And there's some pizza outside, so please take advantage of that. And we'll be around to just chat if you have questions or thoughts.